Hello everyone. Hello. So today let's continue with the next topic in refraction, that is critical angle. So what is critical angle? The angle of incidence in the denser medium for which the angle of refraction in the rarer medium is 90 degree is called the critical angle of incidence of the medium. Let us see this with a demonstration. Let me come to my studio here. You see, I have a medium placed in a vessel. This is water. Imagine these boundaries are very is not uneven, it is straight, and I have placed an object at the bottom of this tank. A single ray is coming from this bottom, coming from this object, and it is getting refracted under at this interface. Now you see what happened. All before this, whatever videos we have learned, if you notice, the ray was outside. The ray was coming from outside, and we used to observe the effect inside the denser medium. Now the ray is been introduced from the denser medium, and it is going from denser medium to the rarer medium. Let's say this black space which you see surrounding this vessel is the air. So now if I rotate it gradually, look at the ray. See what is happening now. The ray is not going. First of all, look at this case. At this point where these two rays, please look here, these two rays, if I neglect it, we can imagine that the ray is traveling along the surface of this medium. And if I annotate it, let me just a minute. Need to change the color, else you won't be able to see. Wait a minute. Change the color to yellow. Then if you look here, this being the normal, this is the angle of incidence. This angle of incidence at which the incident ray, this angle of incidence of the incident ray for which the angle of refraction is 90 degree, we call this the critical angle. Remember, I am explaining once again. The angle of incidence, when the angle of incidence in the denser medium for which the angle of refraction in the rarer medium becomes 90 degree, the angle of incidence is called the critical angle of the medium. Okay, so now if you notice that the ray is going along this side like this, it is going like this, coming this way, and then it is going like this way. Understand? Now if we increase it further, let's say I increase it even further, what will happen? The ray get completely reflected within the medium. This phenomenon of reflection is called total internal reflection. The ray will not go out. So now you notice one thing: the angle of incidence has to be greater than critical angle. The angle of incidence has to be greater than the critical angle. When that happens, the refracted ray will be within the medium and it will not go out into the rarer medium. At that time we will call the total internal reflection is taking place. Understand? So now we are going to learn these two phenomena. First we will learn the critical angle and the maths involved in it. Then in another video we are going to learn total internal reflection and its different application of total internal reflection. So let's come back, let's get back here. So the angle of incidence, so let me draw the environment here properly. So you see, So if I draw that vessel here, or the beaker here, and this is the surface of the liquid, I am considering that it is not uneven. Assumption is it is not uneven, it is completely even and straight, and this being the normal, this being the normal, and object is lying at the bottom of this tank. Okay, then the angle of incidence in the denser medium IC, for which the angle of refraction is 90, we will call it the critical angle. So using Snell's law, we can write sin IC by sin of R equal to, now let's say N2 is the refractive index of this medium and N1 is the refractive index of the second medium. So always we take the next medium in which the ray is traveling into. The ray is going from denser to the rarer, it is going into the N1. So in the numerator it would be N1 and the denominator it should be N2. But for air, N1 is equals to 1. For air, N1 equals to 1, and R, the criteria is for I to be IC, the criteria is that R must be equals to what? 90. So sine of IC by sine 90 equal to 1 by N2 implies I'll write it here, sin IC is equals to 1 by N2. This is the relation for the critical angle. Okay. Now for water, N2 is 4 by 3. So sine of IC will be how much? Let us find out. Would be equals to 4 by 3 equal to 3 by 4. So sine IC is equals to 3 by 4 and IC would be equals to sine inverse 3 by 4. Understand? We can find out this angle, how much is it? Sine, let me tell you, just a minute, hold on, I will tell you how much is it. Sine inverse 3 by 4 around 48 degree, around 48.5, 48.59 or 48.6 degree. This is the critical angle for, you can keep it up to this for also, no problem, 48.56 degree approximately. Okay. Similarly for glass, N2 equals to 3 by 2, therefore sin IC must be equal to 2 by 3. So sine inverse 2 by 3, 41.8 or roughly 42 degree. So IC equals to sine inverse 2 by 3, which gives me 41 point, which gives me around 41.8. We can approximately write this as 42 degree. Okay. Now expression for, now let us take one expression. We'll find out one expression for expression for the conical for the base area of a cone, for the base area of a cone of light originating from a light source placed in the denser medium. I know the title is quite lengthy, but it is one of the application of critical angle. Let's see how is the application. I try to understand the situation first. So I have this vessel here. This vessel or this beaker is carrying some vessel, beaker or tank, whatever you say, is carrying some liquid. This being the normal, and there is a one point source, or imagine a bulb or source lying there. The rays originating from this source after refraction follows along the interface. This is happening when the angle of incidence is IC. So try to understand here, the light coming out from this source will be only up to the IC, because beyond IC, because the ray which will be at an angle of incidence beyond IC, what will happen? It will undergo total internal reflection, which I have shown you in the demonstration. Now we need to find out, similarly this side also same phenomenon will happen. As a result, the light will be coming out in the form of a cone, because beyond IC everything will be totally internal reflected, means all the ray of light coming from, originating from the source, will get reflected within inside. There is no chance of any rays to escape this and go to the rarer medium if the angle of incidence of the ray is greater than IC. So we need to find out, and this will be in the form of a cone. This would be in the form of a cone. So we need to find out what is this conical area. Okay, the expression says that. So let's see how we can derive it. I'll draw this diagram once again. So here is the beaker. This is the surface of the liquid. This is the normal. This is the ray of light. It is originating from here and getting incident at the interface, say at an angle IC, and it is strictly refracted on the boundary itself, and this is 90 degree. So if we could find out the value of this expression for R, then we can easily find out the conical area, base of the conical area. So how we can do that? So if this is IC, this is angle IC, this must be also what? IC. Let's say the height of the liquid level is H, right? So we can say like this, that let a light source is lying at the bottom of a tank which is filled with a liquid of refractive index, absolute refractive index N2, okay, up to a height H. Then using Snell's law, we can write sin I by sin R equal to, now always the second medium first. So if this is N1, this is N2, the ray is traveling into the N1, so it should be N1 by N2, right? Or implies sin I, this is 1, this is sin I C equals to 1 by N2. Why? Because N1 is 1 and R is 90 degree. That's it. So now let's go to the next topic, next page. So now if you look closely, this triangle, from this triangle means tan IC, what can I write? Tan IC can be written as R perpendicular by base. Base is H and perpendicular is R. Tan of IC would be R by H, or sin IC by cos IC is equal to R by H. The value of sin IC I know, cos IC how can we determine it? So if we go back, let me name this equation 1. From, let's say this is 2, from equation 1, sin square IC is equals to 1 by N2. 1 minus cos square IC is equals to 1 by N2 square, or cos square IC is equal to 1 minus 1 by N2 square. So cos IC must be equal to root over 1 by N2 square. Can I plug this value here now? Can I put this value here and the sin IC value there? This is not, don't misunderstand, this is not square, no? This is sin IC. Sin IC equals to 1 by N2. Okay, so if I use this equation, this is, let's say, equation 3, substituting one and 3 in 2, what will I get? Let's do this in the next page. So sin IC is 1 by n2 and cos IC is 1 by root over 1 minus 1 by n2 square equals to r by h. So 1 by n2, I can take, so n2 square minus 1 by n2 square, this whole thing root, bracket close, r by h. So these n2's come out, it becomes n2. So you can understand now it is 1 by n2 by n2 into 1 by root over n2 square minus 1 equals to r by h. So finally the equation r becomes, these two get cancel out, so this r is equals to h by root over n2 square minus 1. So this is the radius of the base of the cone, we can easily find out the area. Therefore base area of the cone will be A equals to pi r square. So pi h square by n2 square minus 1. This is it. Understand? This is how we can easily find out. Let us see one question. I give you this situation here, that this is a vessel, beaker, sorry, and there is a bulb lying 50 centimeter below the level of the liquid. Okay, this is a bulb. So let me write the question. A bulb is lying at the bottom of a tank of refractive index, bottom of a tank filled with water up to a height of 50 centimeter. Find the base area of the cone, base area of the cone so the sentence should be like this: find the base area of the cone of light, cone of light coming from the source. So let's see, this is the question. This is a fundamental question. Now this question sentence can be given in many way. So when I give you assignment, you will get to see how the same concept has been used in different ways. So what is given to you? Given n equals to water, no? Sorry. N equal to 4/3 because it is water. Now height 50 centimeter. So R will be how much? H by root over 4/3 whole square minus 1. So H is 50. So 50 by 16 minus, this will be 4 square for 16 and it is a 9. So 16 minus 9, it would be 16 minus 9, 7 I think. 16 minus 9, 7 by 9. So it is 7 by 9. So 50 by root over 7 by 9, which you can write as 9 square root will come as 3. So 50 into 3 by root 7. Fine. So now let me go to the next page. So area would be pi into r square. So pi into 50 into 3, 50 into 3, 50 into 3 by root 7 into root 7, that gives me 7. So if I solve this, I should get 3.14 into 50 into 9 divided by 7. That gives me around 3364 centimeter square centimeter area. Understand? This is how you can solve the numerical. So let's have a look. Okay. Well then, see you the next lecture, next topic. I will be doing one more. Well, let's start with the total internal reflection first.